Hi there once again, and welcome to another Expresso mechanic tutorial. And this will be a Python tutorial, and in it we are going to be creating what I'm loosely referring to as a stop motion effector. And as you can see, what we've got on the screen is an object that is swaying back and forth, and it's also changing color as it does so, and that's all being controlled by the effector. That's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. We'll start by bringing a cube into the scene, and we'll make it 20 by 100 by 20, and in the Y segments here we'll make this 10. We'll also switch our display to garage shade lines or MB. We can use that if you wish. Coordinates here, we'll make this at 50 so that it's just on the ground. Fantastic. So we've got our first object in the scene and we need to create the rest. Now what we'll do is Command drag to copy this, and I'll just Option G and call this original, and I can switch it out of our scene, and I'll also switch it out of our render as well. So we've just got that there in case we make any mistakes. Shouldn't need it, but I'll put it there anyway. Let's Command drag to copy this, and we'll also add a bend deformer. That's what I want, just one bend deformer. If I can drop that into my object, go into my object, tab, fit to parent, that's fine. Its alignment is correct, and we can now bend our object through 180 degrees. Let's just set that to there. And we can then make this object editable. But what we need to do is actually use current state to object. So we'll do that, and we've done that, and we've got it here. We've still got our original cube with the bend in, and we need to select this again and make it minus 180. And then once again, we can select this and use current state to object. And we've now got two cubes here. We can then throw this into the original because we don't need it in the scene anymore. Now, let's just name these up. So this one, again, we're going to make this editable with our original cube, and we'll call this one straight. This one we will call bend right, and this one bend left. And then we can think about a cloner. Now the first thing though, before we do that, let's just Command drag to copy this one, and we'll place it between our two bends here, and we'll also put bend left here and bend right here. That's the order that I want things in. I'll bring a cloner into the scene and select all of these and drop them into it. We can then think about what we're going to do with our cloner. We don't want grid mode, we want linear. We don't want anything in the Y. And we then need to set up our clones accordingly. We want a count of 41 clones. And we can then start to think about what we're going to do. Now, ultimately, we do want everything in the spot that it's in now. Another thing that I will also do is just switch off reset coordinates so that we leave things as they were. And we can just do this for a moment, just see what we've got. And we can see all of our objects stretching along this path. Now, at the moment, we're not in the right mode because we need to be in blend mode. And now we're starting to see what our animation is going to look like. Let's just reduce this a bit so that we can get them close together. And we can now start to see what they're going to do. Let's go back a bit further. Yeah, that's looking good. So we can see that we're starting with a straight here at climb 0, and then we gradually bend over, and then we bend back to straight, and then we start to bend the other way, and then we bend back and finally come back to straight here. So that's what we're going to do, except that it's all going to happen at 0 here, at point 0 in the world axis. So we can take away our position X's value, make that 0 again, and then just hit H so that we can see everything. Okay, fantastic. So everything is where it needs to be for the moment. But obviously we don't want to see all of the clones at the same time. We want to see them one at a time in order to create the animated effects. And that's where our Python effector comes in. And that's what we need to start working on next. We'll bring in a Python effector and make sure it's within our cloner, which it is. We'll switch to a scripting layout and we can open up our Python effector in there. Just adjust our window. Okay, I think that'll do. Right, let's start getting rid of some of this stuff that we've got in here. For a start, where are we? We don't need any of this. In fact, what I need to do is go to full control. I'll just go to there. We don't need any of this, and let's just get rid of that. And we don't need this Q line either. We're not going to be using any of that, so let's just take those away. We can also take out these comments here and these up here. I think they're just in the way, really. Just get rid of those. Okay, fabulous. So let's start from here and see where we go. We know that this is going to be one of the last lines, so we'll put a gap between these. Now, we've got matrices in here, but we also need a couple more MoGraph arrays. We need the flag array and we also need the color array. So we'll copy this line, paste it in here, and we'll say flags is equal to, and it will be list c40.matrix equals data.getArray. We just need to change the word matrix for the word flags, and that completes that one. Down here we may as well copy this line and we'll paste. In fact, I need the whole line, don't I? I need that and that. That's better. Oops. C, and we'll paste that in there. And once again, we can change the word matrices for the word flags. And we can change matrix for flags. And that completes that one. Moving on, we will also be using the color array, as I've said earlier. So let's just copy this line, paste it in, and say colors is equal to c40.matrix and colors over here, or color I should say. And then once again we can copy this line, paste it in, color, colors. Okay, fantastic. So we've got ourselves that far. We've got our various arrays set up and we've got them to the stage where they will be updated as need be. Let's just adjust that window again. That's better so that I can see all of those lines. That's tidier. Right then, moving on from here, we can think about defining some global variables. And we only need 3. So we can say global visible, counter, and finally index. And you'll see what these are used for as the tutorial progresses. We also need the frame variable that we always bring in, or so often bring in. So frame is equal to doc.getTime .getFrame brackets doc.getFPS open double close, which of course will get our frames from the timeline. We're not actually going to be using a range mapper with a monoflop on this occasion. We will be using 3 range mappers, but we don't need a monoflop, so this is a little bit different to what we quite often do. That's great, so we've got things that far. The next step, we may as well actually get the user data sorted out, because I am using some user data for this to give us more artistic control over what the thing can actually do. So that'll be our next step, to just get that user data done. We've got our Python effector selected. In the user data, we can say and user data. I'll add a group and I'll call it controls. Just move that data down into there. This first data here, I will call FPS, so frames per second. And it will be an integer. The interface will be an integer slider. The step will be 1, and we'll go from 1 to 10 for our range. So that's as far as we need to go, and we'll limit the min and max. So we've got our frames per second set up. Now what we can do with our name here, rather than just simply calling it frames per second, I'll actually say 30, and it will be this. And so it's between 30 and 3 frames per second is what I'm saying here. Just put a space in there. Yeah, and that's fine. That will work nicely for us. So basically 1 will give us 30 frames per second, and if we go across to 10, we'll be at 3 frames per second. That's the way this is going to work. We also need a couple more datas, and these will both be booleans, so we can bring 2 of those in. We'll put them above our frames per second. First one will be called loop, and it will be a boolean, and we'll leave it in the default as unchecked. This will also be a boolean, but we'll call this blend colors, and once again just select that as a boolean. Okay, that's fantastic. So we've got all of our controls set up and ready to go. We can just hit OK, and there they are. So they're down here and they're all waiting for us. We can now think about dragging them in to our editor. So we'll put a little gap. In fact, we'll put it here. We'll just put a gap between these 2 here, and we'll start bringing these in. So we can say loop is equal to, and get a hold of this, drag and drop it in. It'll be in the wrong place as per usual. Come on, Maxon, sort it. And it will simply be op. So we've got our loop in. Blend colors, we'll say blend underscore cull. I think that we'll leave it at that. Bring that in, just drop it. Take it away from there. Drop it here. Is equal to op. So we've got our color blending, and finally we just need our frames per second. So FPS is equal to, drag this one in, put it there, and we've got our user data dragged in, and we've got our variables for them all set up. Right, we can move on from here. We'll define our lists for our colors next. Now we need a list for red, green and blue, and we need actually 2 lists because we need a starting color and a finish color. for our various states. So we'll start with r_start for red start, and it will be equal to, and then we can create a list. We'll start with our initial clone being red, so we'll say 1 in here, comma, and it will be 0, 1, 0. So we're starting with red. Over here we've got red again, and you'll see why as this continues. If we then say g_start is equal to, at first we don't want any green, but we will certainly be wanting green in our second state. We don't want anything in there in our third and fourth states. And finally, B start will be equal to 0 at first, because we wouldn't want anything in there, 0 for our second state. Our third state we do want it to be blue, and our fourth state we don't want anything in there. So we're starting with red for our first state. In our second state we're starting with green, our third we're starting with blue, and our fourth, I've actually got that wrong, that should be there, our fourth should be blue. That's how we should work this out. Okay, those are our 4 states. So red, green, red, blue. That's what we're doing. We then need to work out our finish states. So we'll say r_finish is equal to, initially we want our green state to be our finished state, so we don't want anything in our red. We then need to say our red should be our next finished state. We want nothing from the red in our third state, and finally our last state should be red for the finish. Green_finish will be a 1 there, because we're going from red to green, so that's correct. Then we simply want zeros, because we don't want to use our green again. And then finally we can look at our blue finish. So B_finish is equal to, at first we want nothing in our second state. Our third state we do want blue, and our fourth state we want nothing. So we start with red, we finish with green, we start with green, we finish with red, we start with red, we finish with blue, we start with blue, we finish with red. That's how these states are going to work. We can now move on and think about the next step. Well, we need to define a single function, so we can say def, and this will be called invisibles. And it's a very simple function. We simply need to say for flag in flags. So we're working with our flags up here, our flag array. And this allows us to turn the clones on and off, or make them visible and invisible, if you like to say it that way. So, in fact, what I need to say, I've gone a little bit ahead of myself, for flag in range, and it will be brackets len, brackets flags. That's what I should have said in there. Double close. And then it will be if flag is not in visible flags square brackets flag is equal to 0. We created this visible variable up here, and we will be using that very shortly. So we'll only have one one of our clones stored away in visible at any given time. And that clone will be the only clone that we'll be able to see at any given time, because the rest will be switched off by using this function here. That's what's going to happen. Right, so we've got our little function set up and ready to go for us there. We can now think about what's going to happen at frame 0, and at the moment we've got all our clones visible. We just want our first clone, clone 0, to be visible, and that's what we're going to set up among other things. So we can say if frame is equal to 0, and it will be visible is equal to square brackets with a 0, and that will give us our clone 0 visible, because all of the others will be switched off here. That's what's going to happen a little bit later. Let's step through a little bit further. We can then say counter is equal to 0 and index is equal to 0. We can then think about having a look at whether our colours are to be used or not used. So we brought in blend cull here. So we can say if blend cull underscore cull is equal to true, colours, which refers to our colour array here, colours, and it will be brackets 0 is equal to, and it will be C4D dot vector, and it will be brackets 1, 0, 0, and that will give us a red clone of frame 0. We can then call our function invisibles open close. Let's see if any of this is working, and it is. We've got a single clone. At the moment it has no color, but if we say blend colors, it turns red because of what we've got here. So far, so very good. It's all working as it should. Let's move on from here and see where we go next. We'll give ourselves a little bit more space, and then at the level of our if statement here, we can type else, and then we can think about coding the rest of the Python effector. So if frame modulo, percentage sign for modulo, FPS is equal to 0, we can do something. So whatever we're doing here, at the moment we're working on 30 frames per second because we've got this set to 1. But if it was set to 10, we'd be working at 3 frames per second. So that would be our modulo based upon that. But anyway, let's continue from here. We can then say if counter is less than, and it will be len brackets flags -1. So I've used flags here. I could just as easily have used matrices or colours, but I've just decided to use flags because they are all the same length. They've got exactly the same elements in them, or the same number of elements effectively in them, even though they're dealing with different things. But basically then, flags contains 41 elements, but our counter counts from 0 through to 41, which would give us 42 elements, and that would give us an index out of range error if we didn't subtract the 1, because we only want the 41 elements. So that's why the 1 has been subtracted. We can then say counter, and it will be plus equals 1. So all the time we're less than the length of flags -1, we can keep counting and sequencing through all of these, which have just magically appeared because of a little error there, which we'll soon sort out. Okay, great. So that's working. We can then say at the level of the second if statement, else. And then we can check to see if this loop has been checked. So we can say if loop is equal to true. And if it is true, we'll reset our counter. So we'll say counter is equal to, and it won't be 0, it'll be 1. Because clone 0 and clone 41 are both straight. They're both the same. So we don't want to repeat them, because if we do, there'll be a slight pause in the animation. We don't want that. We want it to loop cleanly. So we must set our counter back to 1. The final line of this little piece will simply be visible is equal to, and it will be square brackets counter as we sequence through each of our clones. Now, if we wish to, we can come back to our level here and we can see if this is working by simply typing invisibles, open, close. And let's see if this actually does work. So if we play the sequence, we find that it does. And we don't loop because we haven't got the loop actually on. If we put the loop on, let's see what happens now. And we can see that it's working perfectly. And if we start adjusting here, we can slow it down. And we can make it step through. We need to give ourselves a few more frames to really see everything. We'll just make that 1000. And let's see what happens. Yep, and there we go. That's all working really nicely. Now, if you get a little bit of orange within this here, if there's a tiny little stripe of orange, you'll probably find that you're going to get an error when you run this sequence of the animation. All you need to do is just move this and move it back, and that orange stripe will disappear, and then everything will work okay. So bear that in mind if you do get a problem with that. Okay, fantastic. We'll take the invisibles away, or in fact what I'll actually do, I'll comment it out because I will need it later on. Let's continue from here and get the next piece of this going. We can then think about how we might deal with our colours. So we can say if counter modulo, and on this occasion it will be modulo 10, because there are 10 clones between straight and bend on this occasion left. That's where we're going to end up. That's going to be our first set of conditions. So we start straight, we end up at bend left. So that takes 10 clones. So we can put equal to 0 there to check to see if this has happened. We can then start working with our index, which we created up here, and we know that at the moment that's 0. We can then say if index is less than 3 and do something from here. It's got to be 3 because it starts with 0, 1, 2, 3. That's what our index is going to be used for, to count through all of these. We can then say index plus equals 1. So all the time we've not reached a high enough number to get through all of these, which obviously is going to be anything less than 3, then we can count. We can then say here else, and again it will be if loop is equal to true, index is equal to 0. So once we've counted from 0 to 3, if we've got the loop on, we want to reset everything back to 0, and we can then start counting from the beginning of these lists once again, sequencing through them. Okay, fabulous. So we've got it to that stage. We can now think about putting the finishing touches. So the next thing we need to check for is whether or not blend colors down here has been checked. So if blend cull is equal to true, then we want to work with our colors, and this is where we need our range mappers. So we can say red underscore range underscore mapper is equal to, and it will be c4d dot utils dot range map. And then we can think about our values. Well, in order to make this work correctly, we need to say counter modulo 10. So in other words, we've got to replicate this, and then the two things will sequence. As this sequences through the clones, it will also sequence through the colors and take us from red initially to green, and so on and so forth. We can then say 0, 10, because we know we're going to count through 10 colors and 10 clones, of course. And then we can think about where we're going from here. Well, our output ranges will be R start and R finish. So we can say R start, but of course it will be with regard to each of these numbers. So we need to use our index. So we can say brackets index, close brackets, and then it will be R finish, square brackets index, close square brackets. So that gives us our start and finish ranges. So it will be basically a value on this occasion between 1 and 0 for the reds. That gets that done, and then we simply need to say comma false, because we're counting from 1 to 0 and we'll have a problem if we don't do that. So that's our first range mapper taken care of. We just need our green and blue range mappers. So the best thing to do is copy this line, paste it in here, and then we can think about setting things up. So for a start, I will need to say green range mapper at the beginning of the line, green range mapper in there. That's the first thing. And then we can think about what we're doing here, and it will simply be G start and G finish. And everything else can stay the same because it's all working in the same way. And then finally, we'll just paste again, make this our blue range mapper. And again, it will be B start and B finish. And that completes our range mappers. We can then say X is equal to red range mapper. We can copy this line. Oops, don't want to do that. Just, where have I gone? Oh, I don't want to do that. Take that away, that's better. Just copy that again. C, and then paste it in here. Y is equal to green range mapper, and finally Z is equal to blue range mapper. And then we simply need to update our color vector. So we can say colors, brackets, counter is equal to, and it will be C4D dot vector, and it will be brackets X, comma Y, comma Z. And then all we need to do is take away this comment, and we've completed the code. So let's see if it actually does do what we want it to. Well, we know that the loop is working, and we know that our frames per second are definitely working. Let's put our colors in and let's see what happens. And we can see that they're working perfectly. Let's just slow things down a little bit so that you can see more easily. And there we go. We go from red to green, green to red, red to blue, and then finally blue back to red, and the loop starts again, and everything is working fine. So there you have it. That's how you code what I'm referring to as a stop motion effector. And it works really quite nicely. Let's just go to 10 so that we get 3 frames per second. But yeah, It works quite nicely. And I mean, you know, the shapes I've done here, you don't have to use them. You can come up with something clever if you know, see what you can do. Have a play around with it, see what you can do with it. And again, with the colours, they don't have to be the colours that I've got here. You can put different values in here and get different colours. You know, and if you've got more clones, then you can adjust things accordingly. If you've got, say, 6 clones, you can have 5 values in each of these, and obviously adjust your various numbers accordingly. But you know, as I say, have a good play around with it, see what you can come up with, and see if you can make it do something more interesting. But that is how you go about creating a stop motion Python effector. And that brings us to the end of this tutorial, because I've shown you everything I wanted to show you in this one. And as always, I really hope that this has inspired you and given you a few ideas for things that you may be able to incorporate within your own projects. And if you have enjoyed the video, please give it a like. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because I do need the views. And all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one. So I'll see you very soon on the next tutorial.